Hey guys, this tutorial is going to show you how to export your existing landscapes into external tools such as Blender or World Machine, and then show you how to import them back into the exact same spot in scaling. And this will allow you to modify your landscapes in external tools pretty easily and get them back in the right spot. So let's get started. So to get started, we're going to make a landscape that we can modify and then export and re-import. So just go to landscape mode up here, and we're going to create a new one and set it to 63 by 63 quads for the section size, and 505 by 505 for overall resolution, 8 by 8 for number of components, and hit create. And then in here, we're just going to make a couple of peaks. I'll make one over here and one over here, just to verify that when we import it, it's the same, and you can do whatever else you want here as well. So then the only other thing we're going to want to do is want to create a box to mark the top of this peak so we can verify that our scaling and everything is correct when we re-import it. So I'm going to go to Add, Shapes, Cube, and I'm going to go to Front Perspective, go to our cube here, and we're just going to use it to mark the top of this peak. So I'll add it there in Front Perspective. And I'm actually going to scale it up a little bit too, make it a little more visible, and we'll make it red as well. There we go. Move it up a little bit. And we're going to go to the left perspective as well and put that on the peak in the X dimension as well. And then back in perspective, we have a little cube to mark where the top should be. So to actually export this thing, all you have to do is click on the landscape and go to File, Export Selected, and we'll name it Tutorial Map Landscape. And I'm just going to put it in my tutorial project exports folder. And when you export, make sure collision's unchecked. We don't need that. You can always delete it later if you do have it checked, but the rest of the defaults should be fine. So hit export. And then in Blender, start a new project, and you just delete everything that it comes with. And we're going to do File, Import, FBX file. And I'm going to go to that folder I just exported to, Tutorial Project Exports. Click on our FBX file. The defaults should be fine. And we'll hit import. And now we have our landscape. You'll notice it clips a little bit when I zoom out. So if you click on the little arrow up here and go to view, you can set your clip start to 1 meter and your clip end to 10,000 meters, and that should fix that. And you can see we have our landscape here. So let's just add some changes here. So keep in mind, for this tutorial, we want to leave all of the X and Y coordinates of the vertices where they are and only affect the Z coordinate. If you wanted to edit the XY locations of the vertices and sort of just create a generic model, you could do that, although you'd need to resample it back to the resolution of the landscape, or at least some resolution that you could import. So for the moment, we're only going to modify Z locations. So first off, let's just add a little texture to this landscape. So I'm going to go to modifiers, add modifier to form, and we'll do a displace modifier. And the direction, I'm going to say Z and set it to global. And then for the texture, I'm going to click new. And then if we go down to textures here, under the texture type, I'm going to go to Musgrave noise. So we'll just add a little bit of noise here. And I'm going to increase the size a little bit. And so now we just have a little bit of texture on our landscape in the Z location. You'll notice that there's these lines, and you can actually see the components of the landscape. So the landscape's broken up into 64 individual squares, and each square has 64 vertices in it. So to get rid of these lines, we actually want to merge the seams. So each one of these components lines up, and it has duplicate vertices along these seams here. So it's very easy to get rid of. Just go to edit mode, and all the vertices are selected. Just go to mesh, merge by distance. And then if you click down here, just move it up to 0.1. The default isn't quite enough to get them all merged together. And you can see it says remove 7,000 vertices down here. And we didn't have to undo the modifier because when you're in edit mode, if the modifier is not applied, the vertices aren't actually in that location yet. So that's all fine. Now if we go back out, you can see those lines are removed and we just have our little texture here going on. So that's great. So now let's say that we're done. We want to import it back into Unreal Engine. So on the right here, I'm going to right click and say vertical split. And on the top left, click on that and go to text editor. And we're going to make a new file here. And I'm going to save this. And once again, going to go to my tutorial project folder. And we'll just put it in scripts. And I'm going to call this Blender script underscore export mesh as heightmap.py. And at the top here, we're going to need a couple imports. So import BPY, import bmesh, and import OS. And basically what we want to do is we're going to get the active object. So bpy.context.activeObject. And just check if that's not null. And just make sure that the type is a mesh. And if it is, we're going to set heightmap info equal to mesh the heightmap of the object, and we'll write this function in a second. And then we want to save the heightmap to some output path. So at the top here, we'll just define some variables that we need you to set in order to run the script. So the first one is going to be that output path. So output path, and we'll just set that to, I guess it can just be our tutorial project folder. And then the other thing the script needs to know is the z-scale that was on the landscape that you exported, so it can divide that out when it's normalizing in order to write it to a heightmap file. So basically we're going to have this exporter landscape as a heightmap again, and then we're going to re-import it and just set everything where it needs to be so it perfectly lines up with where the landscape used to be. So we're going to set z-scale to 100 since that's what our landscape was set to. And down here, we're setting this heightmap info variable. So we need a class to store the output from this mesh to heightmap function we're going to write. So we're going to make that class. So class heightmap info and definite self. And we're going to need the x vertices. So num x vertices, the number of y vertices, and the heightmap. Then self dot num x vertices equals num x vertices. Self dot num y vertices equals num y vertices, and heightmap equals heightmap. All right, so now we're going to write our mesh to heightmap method. So def mesh to heightmap, and that's going to take our active object in. And the first thing we want to do is get the bounding box of the mesh. So we're going to set a mesh equal to object.data, and then we need, we're going to find the min-x, so let's make it 999 for now. And we need the max x, so to negative 999 for now. And we'll repeat this for y and z. So then we're going to loop over all the vertices. So for v in mesh.vertices, and we're going to say if v.co.x is less than min-x, then min-x equals v.co.x. And we're going to say if it's greater than the maximum x, then max x equals that. And once again, we're going to repeat this for z and y. And now we should have our maximum bounds of this landscape. So now we need to determine the number of vertices in each direction. So you could just enter all this at the top, but we're making the script be generic so it can support any resolution landscape, and it's just going to detect the resolution from the vertices themselves. So just make a comment here, determine the number of vertices in each direction. And the num x vertices, we'll start that at 0. Num y vertices, start that at 0. And once again, we'll iterate over all the vertices. So for v in mesh.vertices, and we'll set the x difference to the vertex's x coordinate minus our minimum x, and the y difference to v.co.y minus min y. And then We need to check if this is approximately 0, so I'm just going to write a little helper function up here for that. Oops. So def is approx 0, and we'll take a value, and we'll have an epsilon be passable, but we'll default it to just 0.001, whatever. And if val is less than epsilon, and val is greater than negative epsilon, we're going to return true. Otherwise, we're going to return false. Pretty straightforward. And then back down in our for loop, if the x difference is approx 0 x diff, then we're going to increment our number of x vertices. And likewise, if is approx 0 y diff, then we're going to increment our y vertices. So this isn't super efficient, but basically for all of the values right along the x minimum, so all of these vertices here, and for all of the y vertices on the y minimum, so all the y vertices here, we're just going to increment our count, and this should get us our x and y resolutions. So now we need to know the resolution and the range of these. So make a comment here, determine the resolution. So first, the range on the x-axis is the max x minus the min x. The y range is the max y minus min y. And now we want to know the delta between vertices on each axis. So the x delta is the max x minus min x, or rather the x range divided by the number of x vertices minus 1. And then y delta is the same, but for y, the y range divided by the number of y vertices minus 1. And now we can actually create our height map. So create the height map, and we're going to make an array to store it. So height map equals 0 times num x vertices times num y vertices. So this is going to initialize it to 0, and it'll be num x by num y. And then when you import stuff back into Unreal Engine, it treats 0 in your height map as negative 256, and it treats 1 in your height map as positive 255.992. So we need to keep track of that range. And I'll add a note here on importing into UE, a 1 in the height map, a z scale of 1 will be at plus 255.992, and a 0 in the height map will be at minus 256 centimeters. So if you do 255.992 minus 256, you get 511.992. So we're going to set height map world range centimeters equals 511.992. And we'll need that value in a second so that we can normalize our outputs between 0 and 1. And so once again, we're going to iterate over all the vertices in mesh.vertices. And we're going to get the x coordinate in our output texture. And that's going to be the integer of round of the vertex .co.x minus min x divided by x delta, which is our resolution. And we'll close that. And then y is going to be the same, but with y. So v.co.y minus min y divided by y delta. And then we want the unscaled centimeter z position. So z unscaled centimeter is going to be v.co.z. So this is in meters, so times 100 to go to centimeters, and then divide by z scale so we can normalize between that minus 256 and 511.992 range. And then we're going to normalize it between 0 and 1. So z normalized equals z unscaled centimeters divided by that height map world range centimeters we defined above. And then we're going to add 0.5 to it because this is our percentage of the range, and the center, or 0, is at 0.5, so halfway between 0 and 1. So we're going to shift it by 0.5. And lastly, we're going to assign that to our height map. So height map at x plus y times num x vertices. And this y times num x vertices is the size of each row. It's just how you do a 2D array with one 1D array. And we're going to set that to Z normalized. So now we're just going to return our Heightmap info using that class we defined above. So, oops. Return Heightmap info, and we'll give it the num x vertices, num y vertices, and Heightmap. All right, and then the other method that we need is a method to save the Heightmap to disk. So we need that method. We're going to say def save Heightmap, Heightmap info, and the file path. And first we're just going to get our variables out of that class we defined for convenience. So Heightmap info.heightmap and num x vertices equals Heightmap info.num x vertices, num y. Let me just copy. And first thing we need to do is create a new image. So we're going to do image equals bpy.data.images.new. We're going to call it heightmap. And the width is num x vertices. The height is num y vertices. We want alpha. And we want a float buffer internally. And this is so we can do 16-bit for a little more precision. And we're going to set the file format, image.file format, to PNG. And by default, it's going to save these images in a color space known as linear rec 709, which is I think it's a color space used in TV format. We don't want it to have any kind of color map when it writes this to disk. We want it to be exactly what we write. So we're going to change the color space to image.colorspace settings.name, and there's one called non-color. And this will prevent it from using a color map when it writes to disk. So finally we want to define what the pixels are, so let's make an array for the pixels. We'll do 0 times num y vertices times num x vertices times 4, because there's 4 channels per pixel, R, G, B, and A. And then we'll fill that out, so for y in range, num y vertices, for x in range, num x vertices. We're going to set the height to whatever's at the height map that was passed in at that point. So at x plus y times num x vertices. And we're going to get the index, or the base index, and this is going to be at x plus y times num x vertices, and all that times 4 since there's 4 channels. And then we're going to set our pixels. So pixels at the base index, this is the R value. So we're just going to write it as grayscale. So the first 3 will all be the same height, and the alpha value is going to be 1. This is index plus 1, index plus 2 for green, and index plus 3 for alpha. And then we can set the image.pixels to that pixels buffer. Now, you could set the image pixels directly instead of having a temp buffer, although because the Blender Python library is a wrapper around a C++ library, there's some magic that happens to marshal arrays back and forth, and it actually makes it extremely slow if you do it 1 pixel at a time. So doing it as a whole buffer makes it infinitely faster. And I gotta indent this as well. Then we need to call image.update so it knows the pixels changed. And lastly, we can save it to our file. So image.save file path equals file path. And we just need this should be a colon, not a semicolon. And this should be for v in meshes, or in mesh.vertices rather. And so this should be good. So now if we select our mesh, we should be able to export it to our output directory here. And actually I'm going to change this to // and give it a file name. So just say output.png, whatever. Oh, I missed a slash here. So hit run. And that'll take a second, but if we go to our tutorial project now, open output.png, you can see we have a grayscale image of our terrain. And you can see our 2 peaks here, and if you squint closely, you can see all the random lines that I drew as well. So now we just want to import this back into Unreal Engine. So if I go back to Unreal, I can delete the landscape we have. And I'm going to go up to our mode here and go to landscape. And we'll go back to new like we did before, but this time we're going to say import from file. And I'm going to click on the output.png that we just created. And you can see the resolution is 505 by 505. That's correct. The scale is 100, 100, 100. That's also correct. I didn't check what the location was, but if it was 100, we'll move that. So the sections per component was 1 by 1, and we want the resolution to be 505 by 505. And you'll see it updated the number of components in X and Y to match that as well. So I'm going to hit import, and you can see our landscape is back. It is scaled correctly, and I believe it's in the right place. Maybe it was 100 off. There we go. Yeah, that 100 location was there. Yeah, so that's how you export to Blender. You can do some modifications, and you can import it back in. Now, you might be wondering why there's no noise on the terrain. It's because I didn't apply the modifier. So if I go back to Blender, I can just say apply, and then I can run this again. And then back in Unreal, we can redo this process really quick. So import from file, 1 by 1, 505, 505, and 100, import. And you can see now we have our texture as well. So for the last part of the video, I'm going to show you how to use the Heightmap that we exported from Blender in World Machine. So now you can effectively go from Unreal Engine to World Machine, modify it, and then import it back into Unreal Engine. And so if you haven't used World Machine, it's an algorithmic way to create landscapes, and it works pretty well. So this is an empty project. We're just going to delete all the tutorial stuff. And the first thing we want to do is create a generator and click File Input. And we also need to set up our project a little bit. So I'm going to go to Project Settings, and we have to tell it what the range of the landscape we want, both the width and the breadth, as well as the height. So if you look at the landscape in Unreal Engine, each vertex in sort of the natural state is 1 centimeter apart. And so the natural width and height of your landscape, or width and breadth of your landscape, is going to be the number of vertices minus 1, essentially. So we have 505 by 505, so it's going to be 504 centimeters by 504 centimeters. So that's our width and breadth. Now in World Machine, it pretty much just uses kilometers and meters, so we're just going to work in meters and pretend it's centimeters. And we're going to normalize at the end anyway, so as long as we're consistent, it doesn't matter. And so we're going to do 504 meters by 504 meters, and then this will be 252 meters by 252 meters for the origin. And if you go to project setup, you can set the height as well. And so our height span is that same 511.992 number that we used in Blender earlier. So we'll enter that. And that will set up the size of the landscape that we're going to export. So then on file input, we can double click on that, and we need to set the file to use. So I'm going to open up our project once again and scroll down to output. And then we need to specify the width and height that this height map represents as well. So this will be the same. So 504 meters by 504 meters. And we need to specify what the values in the file mean as well. So I'm going to, under scaling type, select specify range, and the lower number here corresponds to the smallest value in your PNG, and this number corresponds to the highest value in your PNG. And these numbers are in meters. And so we actually have to go to our project and measure this somehow. So I'm just going to measure it in the editor. You'd probably want to actually get the real bounding box of this, which you can get in code or in a blueprint or whatever. But we'll just measure it here real quick. So it looks like it's about 68.68 or so. So we'll take that number. So that's our overall size. And the bottom of it, which is where this is going to start, is about at 0 in Unreal. And so that's going to be 256. And the reason it's 256 is because as far as, in Unreal Engine, it goes from negative 256 to 511.9. As far as World Machine is concerned, 0 is where Unreal's negative 256 is. So we need to shift everything up in World Machine's view of the world. So we're starting at 256, and we're going to go to 256 plus that 68.68 number that we just measured. So we can get out our calculator. 256 plus 68.68 And so we're going to go to 324.68. And now we've told World Machine what the range in our file is. And we've told it what the total range of the landscape can be. So you can see in the preview window, our peaks are there now, and you can see our landscape. And so now we need a way to export it. And so if you go to Output and go to Height Output, all you need to do is connect our primary output here to the primary input of Height Output, and that'll handle that. But we could also modify the file before we do that. So let's do a quick operation on it. So I'm going to go up to Generator. I'm going to click on Shape right here, and double click on Shape, and we'll just make a circle at, I guess, the top right here. And if we click on that, we can set its height. So, and change the fall off a lot. So it'll just be this little mound over here. And then if we go back to our device work view, let's say we just want to subtract that from our landscape. So we'll go to Combiner, and I'll add a combiner here, and double click on that and go to Subtract, and we'll give it full strength. So we can put that in line here, connect it up, and subtract out our shape. And if we click on the height output, you can see now we have a big hole in our landscape over here. Okay, so now I'm just going to go to Export Terrain Files. We'll build, and we'll export. And actually, before we do that, let's save it. So I'm going to save the world and go to our usual tutorial project and put it in exports. And then we'll go back to export terrain files and export all. So we can close that. And now if we go back to Unreal Engine, I can go to perspective, can zoom out, delete the existing landscape, and once again go to the landscape editor. We'll import from file. And this time if we go to exports, we can take the World Machine export and set up everything the same as it was before. And one thing I noticed is the overall resolution isn't correct in the Heightmap file. You see it's 1025 by 1025, so we actually want to fix that. It should be 505 by 505. Project settings. Up here we can select custom and 505. Hit OK. And we can save. And then if we go export, we can rebuild. Export all. And then back in Unreal Engine, we'll just select the file again. Now we have 505 by 505, that's good. So now sections per component is 1 by 1, and 505 by 505, and import. And there we go. We've just gone from Unreal Engine to World Machine and back, and now we have this fancy hole here for no apparent reason. And you can see our red box is still right on top of that peak. And so all of the coordinates are correct. And that's how you do it. One thing I didn't mention, if I go back to Blender, we did everything in a Python script to generate the height map for this. And that means that you can't move any of the XY locations on any of the vertices. Another way to do this is you could point an orthographic camera from top down and fit it to the 505 or whatever the resolution was by 505. And then you can, in your shader editor, you can set up the shader nodes such that it outputs the range that you need the same way we did in the script in the PNG file instead. I think it's a little clearer what you're doing in the script than it is in the shader editor, but it could be that I'm more used to code than shaders. But this is another way to do it, and it's very similar to making bump maps, if you've ever done that for models or whatever in Unreal as well. But if you would like a separate tutorial on how to do it with the camera way, and so you could sort of do arbitrary resolutions and that does the resampling for you as well, let me know in the comments and I can do a video on that as well. But that's going to do it for this video. Don't forget to like and subscribe if you like the videos and want to be notified of future ones. Thanks everyone for watching. Have a good one.